Welcome to another video. In this video we are going to learn about some properties for sound manipulation that the instrument Simpler has. Yes. In a previous video we've learned the basics of how to load a sample into Simpler, and we learned about the three modes. Yes, classic, one shot, and slice. And this is where we're at. I think we had the Bessie Jones sample. So I've created this small fragment of a small musical fragment using slices from that sample. Yeah, so let's listen. Whenever I can find my mouse, we'll listen to this fragment. There you are, mouse. Thank you. And let's go.
Here come humming, and here come humming, this is feel. Here come humming, and here come humming, this is.
So it's looping a little bit out of the bar.
Here
So
come humming, and here come humming, this is feel. Here come humming, and here come humming, this is feel.
okay, so now that we've had that going, I can I'm going to introduce some other, as I said, some other components of Simpler that we haven't seen yet, and that you can find under controls. If I click on that tab right there, I will see some other available options within Simpler instrument. Yes, so we're going to start with the leftmost, which is a filter. Yes, we already learned what a filter is, and that's simply what this one is. We can change between the different modes of Simpler, of this filter, and it could be a low pass filter or high pass filter or band pass filter. So I'm going to demonstrate those.
Here come humming, and here come humming, this is feel. Here come humming, and here come humming, this is feel. Here come humming, and here come humming, this is feel. Here come humming, and here come humming, this is feel. Here come humming, and
Filters in Ableton have also the additional possibility of introducing some distortion, which I sometimes find very interesting. And you can do that distortion, you can access that distortion by enabling different algorithms that emulate analog filters which introduce distortion. Yes, these are the ones that are available. And once you notice that once I enable one of those filter algorithms, then I get another additional knob or parameter, which is the drive. Yes, this will introduce some type of distortion, will make the overall sound louder. Yes, but also introducing some distortion. So oftentimes you may want to raise the drive, but as well perhaps potentially release the output volume if you want your sound not to be so loud but have a bite of distortion on it.
Here come humming, and here come humming, this is feel. Here come humming, and here come humming, this is feel. Here come humming, and here come humming.
So that's the filter essentially in a nutshell. We also have an envelope for the filter. Yes, this means how will the filter activate in time. Yes, we can make the filter just happen. If we don't turn this filter envelope on, then the filter is actually just working. It's present all the time.
Here
Yes?
come humming, and here come humming, this is feel.
How about if we wanted that wah wah to happen all the time? How about if we wanted the frequency of the filter to be wah 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 at all times? So let's try to do that with the envelope. Yes, remember, an envelope is a function of time, so it will control one aspect of sound or one parameter, how it behaves in time. So we can say we're going to turn the filter envelope on, and we need to raise some amount here. We need to make it so that if it's in 0, it's not really doing anything. And we can say, you know what, it's going to take a moment to this is how much, this is the attack portion of the envelope, so this is how much time it will take for the frequency to achieve the maximum value. Yes.
Here come humming, and here come humming, this is feel. Here come humming, and here come coming. Just feel come coming, and here come.
So now you hear that for every new slice of a sample is the filter is opening gradually. Yes. So just to clarify, what this is controlling is the frequency of the filter. Yes. And it is the same as if I was doing this manually over time for each new note. One, 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 one. Welcome, welcome, one, right? Because I'm controlling that behavior with an envelope. We're going to turn off this envelope right now. We're not going to use it, so we're going to say, okay, the filter is just behaving like that. Its frequency is not being modulated by anything else. Or we can actually think, okay, can we modulate it in some other ways? Let's try that. You can actually modulate the frequency of the filter, yes, where that cut happens in the frequency range. In addition to controlling that with an envelope, as we've just seen, you could control that with an LFO. And Simpler has a built-in LFO here that we can use. So previously, when we were learning about beep modules, we had a specific device that was an LFO, and we connected that device with a virtual cable to our destination, and that's how we assigned modulation sources to modulation destinations. Now, how do you do that in Simpler? The way you do it is by increasing the amount or the percentage to a value other than 0 in this 4 possible destinations for this LFO. Yes, so that's all the destinations that are possible to control with this LFO. Yes, so the filter is here. Yes, so we can actually raise this and see what happens.
Welcome, coming, and welcome, coming, just feel 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 welcome, coming.
So what we're hearing is that at the rate of 1 second, because the frequency of the LFO is 1 hertz, down here, the filter is opening and closing, yes, in a sinusoidal fashion. So that is now independent from what key of whether I am triggering a key or not in the sampler itself, or let's say independent of whether a new MIDI node is being triggered. Yes, before, when I was controlling the filter's frequency with this envelope is triggered at when any new MIDI node is coming into. Yes, so that's why we were hearing our result was for each new note. That filter was being modulated in the same way. Now this other way so far is let me go back to the frequency view. It's independent from whether new notes are being are coming in or not. We can demonstrate that by changing the frequency of the LFO, and notice that we're just gonna try a very fast and very slow one.
Welcome, coming, and welcome, coming, just feel welcome, coming, and welcome, coming, just feel welcome, coming, and welcome, coming, just feel welcome, coming.
So that's a very slow one, and I could go really crazy and make it very fast.
Welcome, coming, and welcome, coming, just feel welcome, coming.
So that's how you modulate the filter with an LFO. But now we've made that modulation independent of any whether MIDI notes are coming in or not. But we can also make that that is also possible, and by that I mean the ability for the modulation to happen for each new note in the same fashion is also possible when using an LFO, and that's when we are going to introduce this little button that is an R and stands for re-trigger. Yes, I think we've seen something like this in the beat modules, and that's what it's doing. It's going to be to start this LFO modulation from scratch, or from this very beginning of the waveform for the LFO for every new note, any new MIDI note that is coming in. So when I turn the re-trigger on, now the LFO is also kind of listening to the MIDI incoming notes and is starting every time with a new modulation pattern. Yes, I can change where that starts with the offset. A parameter allows me to change that. If I want, let's say I want each and new note go from very bright to dark, then I would introduce some offset so that this LFO wave starts at the very highest peak and goes down. Yes, so this is how it's going to sound, and the frequency right now it's at 131. So let's see. Yeah, that sounds like it's going to achieve the results that we want. So you see how we can also use the LFO to modulate in a way that it is paying attention or following the onset of each new note. Okay, so then we also have some other parameters right here that are available to us in the modulate. We can also modulate the volume. Let's do it one by one, because otherwise it might be too much. We could modulate the volume of each note. And I think this might be more interesting with re-trigger off. Yes, we can obtain what we call a tremolo. Yes, just a fluctuation in how a sound is, in how loud a sound is. Yes, and I think we need for that to be very. We want a higher value. Yes, 100%. We're going to make it very extreme. And I will slide the frequency of it so that we can perceive the different ways to use it. And that's where we're getting, so that this tremolo effect, and I think it's pretty extreme now to have it 100%, so I'm going to bring it a little bit lower so that we get some kind of tremolo effect, but it's not as aggressive, let's say. Okay, so that's that, and again, you can see the other options that are available. We could, or maybe let's leave it like that and add some panning modulation. Now the problem here is that the frequency is the same for whichever parameters we're modulating. So I don't find myself usually often using several destinations at once with this single LFO, since but that might be the case. Yes, just note that now you're restricted to one possible frequency of that modulation. Yes, so a pitch is also possible. And this could be pretty extreme. I tend to use pitch in a more subtle way sometimes. Yes, with a small value, which could add some kind of detuning, feel that could add something to the music. And perhaps slower. So that's at a place where it's quite subtle. And I think depending on the musical context, this could be musical to use or not. So that's what the LFO is. That's how some things. Of course, you can change the shape of the wave itself. You can make the modulation be a square wave, which is much more. It has a different effect. For example, that is certainly not very musical. Yes, because we're changing the pitch in a square wave fashion, which certainly doesn't make sense. But if you have one, that uses the square wave for a pitch modulation, I would be so, in a musical way. Maybe that's possible, and I would be very intrigued in listening to an example like that. Yes. Lastly, here we have a pitch envelope. So in a similar way than before we changed or modulated the filter's frequency, excuse me, first with an envelope, and later on we did it with an LFO. Similarly, we've already modulated now the pitch with a LFO first, but we can do that as well with an envelope. So that's, I mean, I can demonstrate this, but I think it's more or less kind of makes sense, or it's pretty straightforward. So I'll briefly demonstrate this. Again, you have to set an amount here. Seems like 48 semitones would be a lot, so I'm gonna just go for like something like 8 semitones, or and put a longer attack time. So we'll hear for every note that it sort of wants to slide up, yes, or maybe even less than 8, yes. Yeah, not so musical in this example, I feel, but you get the idea. There might be some other cases in which this is a musical use of a pitch envelope. I've certainly used the pitch envelope for other purposes. One purpose that sometimes you can use it for, is more like a trick, is that you can set quite a high amount and a very low, a very short attack time. Yes. So now each sample will contain a very sharp descent in pitch at the early onset of the sound, resulting in somehow a bite of the sound at first. So I'm going to demonstrate this by first starting it with a longer attack time. Excuse me, I'm not doing this right. Then it would be a decay time. Everything applies, but it's the decay time. So a long decay time, so we'll hear that first, but then as I shorten the decay time, then at some point we won't hear that as a gliss down, but we'll hear that just simply as a bite or a sound in the early onset of the sound. So you can see, like, we have this choo. Perhaps not the most musical example to put this with, but maybe with a shorter amount here, a smaller amount. You can see how we're adding something at the very early onset of the time, and there's certainly one sample there that starts with silence, so it's on that one doesn't make a lot of sense. But okay, that's what the pitch envelope is, and there are some then there's an amplitude envelope available, but that's available only on classic mode, and I think we'll look at that when we get to see when a little bit later on this amplitude envelope will use it. Yes, so it's only available, as you can see, when we have the sampler in classic mode, and yeah, we'll get to that. But for now, we in the mode that is the slice mode, then then sort of the amplitude envelope becomes this knobs that are fade in and fade out, which is sort of an envelope as well. Yes, I can make each sound fade in. And finally, I think the last one that I want to show you is potentially very useful. Is just to transpose. Yes, so I can turn off the pitch envelope, but simply transpose this sound. Now this transposition is also playing the sound, playing the audio file faster. Yes, so in this musical example that I'm showing right now, it's throwing off the rhythmic feel of what I had recorded. So not very useful in this case, but this might be something that you want to use depending on the musical situation. Yes, so transposition is available, as well as detuning, which is another form of transposition, but in the smaller range. Yes, transposition goes in musical semitones, and the tuning goes in cents, which I don't know if I said this in an earlier video or not, but cents, we have 100 cents per semitone. Yes, so if you want to detune things slightly, then the tune is for you. If you want to transpose things to fit them into a different key, then you might use just the transpose parameter by itself. Yes, so that's what we have in this flip side of simpler, where we have some additional controls that will allow us to manipulate the sound in various ways that will, you know, somehow empower us creatively to get sounds and make them part of our, you know, the universe of our composition or song. Yes, so I hope you enjoyed this video, and thank you very much.